In this video, we will learn how to factor the sum or difference of two cubes. Now, this equation is not easy to derive, so we just have to memorize this one. On the left side, we have the sum or difference of two cubes. So take note, both terms are perfect cubes, meaning for each term we can get a square root. The factors of the sum or difference of two cubes consist of a binomial factor and a trinomial factor. The binomial factor is simply the sum or difference of the cube roots of the terms in the given binomial, such that this x here is the cube root of x cubed, and y here is the cube root of y cubed. Whatever the operation in the given binomial is, that is the operation in the binomial factor. Now, how about the trinomial factor? We can write this trinomial factor using the binomial factor. Take note, this is the binomial factor. And yes, we use the acronym BF to represent binomial factor. Again, to write this trinomial factor, we use this binomial factor as the reference, not the given binomial. The first term of the trinomial factor is the square of the first term of the binomial factor. Again, this first term of the trinomial factor is the square of this first term in the binomial factor. So, x squared is the square of x. And since this is squared, the first term is always positive. The second term of the trinomial factor is the product of the two terms in the binomial factor. So, this second term, x times y, is simply the product of x and y, the product of the terms in the binomial factor. Now, the sign of the second term is opposite the sign in the operation in the binomial factor. The third term of the trinomial factor is the square of the second term in the binomial factor. So this third term is simply the square of this second term in the binomial factor. So since this is squared, the third term is always positive. Before we consider any example, let's remember the first step in factoring any given expression, that is to factor out the common monomial factor. Okay, first example. Let's say we have to factor x cubed plus 27. First question, do we have a common monomial factor? No, because we have here only 1, and on the second term we have 27. The second question is this a sum of two cubes? Okay, so yeah, that's because you have here plus. Okay, so can we get the cube root of the first term? Yes. Can we get the cube root of the second term? Yes. So this is a sum of two cubes. Okay, to factor, let's get the cube root of x cubed. That's x. The cube root of 27 is 3, since 27 is 3 times 3 times 3. By the way, if you still find it challenging to get the cube root of an expression, please refer to the video on how to get the cube root. Okay, anyway, let's go back to this one. How do we write the trinomial factor? Okay, first term is square of the first term in the binomial factor, so that's x squared. Okay, you have here plus, therefore the second term here is minus, opposite. Okay, second term is product of these two terms in the binomial factor, so x times 3, that's 3x. Okay, and the third term again is always plus, because that is simply the square of the second term in the binomial factor. So 3 times 3 is 9. Second example, let's say you have to factor 3a cubed minus 24b cubed. Okay, first question is, do we have a common monomial factor? Yes, because you have here 3 and 24 contains 3. So we factor out 3 first. Okay, so if we do that, what's left of 3a cubed is a cubed. And to factor out 3 from the second term, we have to divide 24 by 3. So we get 8, then b cubed. Next question. Is this binomial a difference of two cubes? Can we get the square root of this one? Yes. Can we get the square root of the second term? Yes. So this is a difference of two cubes. To factor, let's copy the number 3. Okay, get the cube root of a cube, that's a, minus, okay, same operation. Cube root of 2, rather, cube root of 8 is 2. Cube root of b cube is b. Now to write the trinomial factor, okay, first term, square of this, a squared. Okay, you have here minus, so the second term in the trinomial factor is plus. Second term is the product of these two terms. So a times 2b is 2ab plus this. Remember, the third term is always positive. Okay, because that is simply the square of the second term in the binomial factor. That's the square of 2b. So square of 2 is 2 times 2, 4. Square of b is b squared. Third example. Okay, so you have to factor 8m cubed plus n cubed. Do we have a common monomial factor? No, because we have here 8 and on the second term you have 1. Okay, and the variables m and n are different. Okay, the next question is this a sum of two cubes? Okay, can we get the cube root of this term? Yes. Can we get the cube root of the second term? Yes. So this is the sum of two cubes. To factor, let's get the cube root of 8, that's 2. Cube root of m cubed, that's m. Okay, plus, you have the same operation. Cube root of n cubed is equal to n. To write the trinomial factor, let's get the square of the first term here, 2m, okay, square of 2, that's 4. Square of m, that's m squared. Since you have here plus, the second term in the trinomial factor is minus. Okay, for the second term, let's multiply these two terms. 2m times n, so that's 2mn. Okay, plus, again, the third term is always positive. Okay, square of n, that is n squared. Okay, fourth example, let's say we have to factor 27p cubed minus 8q to the 6th. First question, do we have a common monomial factor? No, because 27 and 8 do not have a common factor and p and q are different variables. Okay, is this a difference of two cubes? Let's check. Can we get the cube root of the first term? Yes. Can we get the cube root of the second term? Yes. So this is a difference of two cubes. To factor, let's get the cube root of 27, that's 3. Cube root of p cubed, that's p, minus, we write here minus, the same operation. The cube root of 8, 2. Cube root of q to the 6. So divide this exponent by 3, so you get q squared. Okay, again, to write the trinomial factor, we use this binomial factor as the reference, not the given binomial, remember? Okay, first term, square of this first term. So you have square of 3, 9. Square of p, p squared. Second term is opposite the sign in the binomial factor. So you have here minus, therefore you have here plus. For this second term, we have to multiply these two terms of the binomial factor. So let's multiply the numbers first. 3 times 2, 6. Then you have p q squared. So times p q squared. And then for the last term, that's plus square of this second term. 2 times 2, that's 4. Square of q squared. Multiply the exponent by 2 to get the square. That's q to the 4. Lastly, we have this example. Let's say we have to factor 64 plus 125 times y to the 9. Okay, first question, do we have a common monomial factor? No, because 64 and 125 do not have a common number or factor. Okay, is this a sum of two cubes? Let's check. Can we get the cube root of this one? Yes. Can we get the cube root of the second term? Yes. So this is a sum of two cubes. Okay, to factor, let's get the cube root of 64, that's 4. Cube root of 125 is 5. Cube root of y to the 9, so you simply divide the exponent by 3 because it is cube root. So you get y cubed. Okay, since you have here plus, the operation in the binomial factor is plus. Okay, to write the trinomial factor, okay, first we got the square of the first term in the binomial factor. So 4 squared, 16. Since you have here plus, the sign in the of the second term is minus, opposite. Okay, the second term is the product of the two terms in the binomial factor. So we have to multiply these two. 4 times 5, 20. Then you have y cubed, so y cubed. Okay, plus, okay, the last term is again the square of the second term in the binomial factor. So 5 times 5, 25. Y cubed square, or the square of y cubed. So multiply the exponent 3 by 2. That's y to the 6. If you have any questions, please leave a comment.